tooling platform that helps you find dependencies in your ServiceNow projects. Um I'll quickly share my screen and then start the presentation. Let me know if you can see my screen. Otherwise, just call it out.
Can see your screen.
Okay, we'll go into the full mode. So the as as mentioned, the name of the talk is AI can write code, but it cannot see the system. And the reason why I came up with this phrase is because as I was working through declarative platforms and also on building microservices, I saw that whenever I ask coding agents to make changes to the system for the artifacts that we have or for the functions that we have within the application, especially large enterprise applications. The challenge is that it makes the changes that looks correct. It also makes changes that looks really plausible code, but it always came back to me uh, with code that breaks during runtime. And we will go ahead and see why and how and and how Fluent-Graph helps us address this problem as a solution. So the the script that you see on the right is a ServiceNow Fluent SDK's declarative language, where it allows us to create a table. And the one specific table that we see is of customer. And as the schema says, that it has three attributes, which is essentially the columns in a table, be it that's the customer ID, the name, and the email. When I go back to the coding agent and ask, hey, can you rename this email ID, email column string to email ID? It would definitely do so. So the question is not, does this file compile? Because the compiler would definitely run it. But I always had the challenge of what breaks when I make this change. So the AI was really good at writing local code, but never had the scope or the way of looking through the whole enterprise application to understand what the consequences are on looking through when making this change. But then, as a developer, I know that the change that I asked for when I looked back is not just uh, pertaining to the place where this table is defined and where this column has to be changed. I've used this column in multiple places. For example, in the real example that I have, it has been reflected in client scripts, business rules, multiple tables as foreign key references, which is the most common way of having tables built in our everyday RDBMS structure. So the challenge is that most of the times the AI tools, the coding tools, never had the full picture of this blast radius. So that one field has many what do you say, the runtime failures. So AI always went ahead and changed the field names, renamed everything, deleted everything pretty confidently, but it was always self-contained. And so how did we so this is the problem statement of having of having to use coding agents in everyday work to build faster. So essentially AI has commoditized generating code, but it has never had the context or the visibility into what breaks when it makes changes or it builds new features on top of the existing code base. So the answer is Fluent-Graph. Fluent-Graph comes in a CLI for the developers to visualize the changes even before the change is made in the system. Fluent-Graph also comes with an MCP where the AI agents it can directly call and uh, realize and observe the blast radius at the point of change, not as a side effect of the change. So all the tools that we have today in at the disposal for us, be at the developer end, be at the CI/CD gates, or be at runtime, uh, is to observe the things in production after the change has taken place and the execution has been done. But then Fluent-Graph comes into the place where you can have that as a pre-execution substrate in any of the uh, coding agents that we use. So we can quickly go and look at one of the real-time uh, uh, on how Fluent-Graph works. So I am in one of the applications that has this declarative platform, and as you can see, when I say Fluent-Graph analyze, it actually detects the SDK, loads the workspace, and then it builds a graph. So it says it's built a graph with 94 nodes and then 93 edges, and it shows you a lineage map on what all artifacts or what all details that we have, be it a function, table, a script, everything. And it gives the developer an insight. So this is the Fluent-Graph CLI, which can be used by a developer before actually making a change. Also, as I was speaking, this is the blast radius command that the Fluent-Graph exposes. And once we pass in the artifact that we want to visualize or wants to know the blast radius of it, it does an analysis and then it comes up with the direct impact, which is if you make a change, it would immediately break something, and then there's a transitive impact as well. So it flags you as a risk level, which means the same command can be used in CI gates to stop a code pull request from getting merged, or an approved pull request from getting into the system, and stop from deployment. Oops. So the other challenge that I've noticed as I was working through the uh, code bases, and also while building the open source Fluent-Graph itself, is that no matter how many agent command MD files you have, the agent actually greps through the uh, application to understand and analyze the code to get that graph that it needs to build to understand the changes and the impact. The challenge is that most of the time the grep commands are at surface level, and it kind of missed uh, what the consequences are when we make a change in the system. So what Fluent-Graph now has is also that it gives the context, a specified confined context to the agent, so that it doesn't have to do a grep or doesn't have to read through the whole files in the whole file system of the code base that we have. So the goal is not to stop the AI from writing code, but the goal is to make the AI systems actually be aware of the code base that it is working on to make the changes or write the code. So Fluent-Graph exposes a command which actually gives the agent the change request. So the token metrics, if you see that, if we use the context, the confined context that Fluent-Graph gives, it just needs 215 tokens to understand and make the code change. But if it has to read the full graph, it would have collected 16,000 tokens or over to make one small change that we have requested, which is just rename the the field from email to email ID. So that's how big of a difference building the context specific to the change makes. And as we all know, context is the next engineering challenge that every AI system is trying to conquer, be it from the frontier model companies that are building these, or the agents that are running in loops, or the agents in multi-agent systems. The context has been the costliest thing to deal with, even though we have short-term lived memory or the persistence layers to uh, get the context back into the agent and fed. But Fluent-Graph makes it seamless to understand the system for the coding agents. So what essentially Fluent-Graph brings into the SDLC cycle, or the uh, build cycle in the current context, is that we are moving from reactive observability to a pre-execution reasoning, which is before some change can take place. At that time, what would be the consequences of that change if it had been done? So instead of making a change, deploy it to the system, observe it, and when it breaks, go debug it and then fix it. What Fluent-Graph does is that whenever there's a change that's coming in and the coding agent has to change, it does understand the dependencies, does understand the system as a whole rather than bits and pieces by doing a grep. And then when it understands the system, it builds that confidence to generate a safer code, which is not just plausible code, but actually helps uh, devs, the developer teams to deploy with confidence. This is one of the Fluent-Graph UI screenshots from the toolchain of the Fluent-Graph, where, as we can see, the developer or the CI gate or anyone in the team can visualize how each of the dependencies are and how they interconnect and how they work together to realize the system that runs and what breaks when something changes. Uh, so as we were speaking, the pre-execution reasoning gives us the power and the ability, not just for us as developers, but also to AI, to make changes in enterprise software by using dependency graphs rather than doing grep commands and reading through huge context and millions of lines of code. No matter how big the context window is, dumping it with all that we have from enterprise code base makes the systems hallucinate. And also the plausible code that it generates would eventually break at runtime. So that's the that's what Fluent-Graph tries to minimize as an open source software. So AI should understand the consequences in the system that it operates on. You can feel free to connect me at my email, which is yesprasad.com. I'm open to connections on LinkedIn and look forward to your feedback.